We've already seen that we can calculate angles, or the sine, cos and tan of angles. What we're going to do now is look at a concept called the unit circle, which allows us to calculate the sine, cos and tan of any angle. Not just angles that are acute, that is less than 90, but angles that are bigger than 90 or bigger than pi on 2, which is the same as 90 degrees. Okay, so we have this thing called the unit circle. The unit circle, because of the word unit, means it's got a radius of 1. So the xy plane is what we call the Cartesian plane. O is the origin. The origin is where the x-axis and the y-axis intersect. This is positive x in this direction, this is negative x, and this is positive y and negative y. So if we draw a circle of radius 1, so that point there, so we've got a circle there, radius 1, center being at the origin. This would be the coordinate. You always put the x first, 0. This would be the coordinate. Now the x value goes first, which is 0. The y value would be 1. This point here. Now this is the negative x direction, so it comes out because it's a unit circle of radius 1. This would be minus 1 or negative 1, 0. And this one here, the x coordinate is 0, but the y, this is the y, negative y direction is negative 1. So that's our unit circle, and that's something that you should be able to replicate, to be able to do it in your sleep if need be. Now, we're going to have a point P that moves around the circumference, and I'll just put it there for the time being. Point P will move around the circle. Point P will start here, and as P moves, it makes an angle at the center, which we will call theta. Theta just stands for any number of degrees or any number of radians for that matter. So this is where it starts. So here, this corresponds to theta equals 0. 0 degrees or 0 radians. So when P is there, that's 0. When P around here, it's gone through 90 degrees. So when P is there, that's 90. P over there, 180, etc. So this, as P moves that way, is the positive direction. But if P moved this way, don't forget that's 0. If it goes that way, this will be the negative direction. So if you had minus number of degrees, it'll be down here somewhere. So this is the negative direction. So this is just a convention that's been set up. Positive direction is anti-clockwise. And this is the way the hands on the clock move around this way, so coming around there, so this is clockwise. So this is 0. Okay. One thing before we start looking at working out sine, cos and tan of theta is that we should know the quadrants. This is the first quadrant. This is the second quadrant. This is the third quadrant, and this is the fourth quadrant. Okay, it's just once again a convention to get used to. First quadrant here, second quadrant is in there, fourth quadrant is down there, and the fourth quadrant is down the bottom there. Okay, now if we had point P and its coordinate was x, y, and we dropped a perpendicular down onto the x-axis. Now that means to get the x value of point P, we've come across to there. So that length in this triangle, that would have a length of x. And to get this y coordinate, we've come up to that corresponding point there. So that is have length y. And you can see in this triangle, it is a right angle triangle, that the sine of theta is equal to opposite over hypotenuse. Now it is a unit circle, so it has a radius of 1, and that means the hypotenuse is 1. So sine of theta is opposite over hypotenuse, which is y over 1, which will be just equal to the y value, or the y value of that coordinate there. The cos of theta is adjacent over hypotenuse, so that'll be x over 1, which is just equal to x. And the tan of theta will be equal to opposite over adjacent. The opposite will be the y value over the x value. If you go back and have a look up here, y is equal to sine theta. So instead of that y on the top there, I can put sine theta over cos theta. So that applies not just for P in the first quadrant, but P as it moves its way around the whole circle. So let's look where P is at the point P1. Now so P now is up there. At P1, what's the x and y coordinate? The x coordinate up here, we've already said, is 0, and the y coordinate is equal to 1. Okay, now what's the value of theta? If P starts here and goes through there, how many degrees or has it gone through? It's gone through 90 degrees. So at P1, which is the coordinate 0, 1, theta is equal to 90 degrees. Using this, we can work out what the sine of 90 degrees is. Theta's 90 up here. It's just equal to the y coordinate. What is the y coordinate up here? The y coordinate at P1 is equal to 1. So the sine of 90 is equal to 1. The cos of 90 degrees, cos is equal to the x coordinate, and the x coordinate is equal to 0. The tan of 90 degrees, tan is equal to the y coordinate over the x coordinate. The y coordinate is 1 over 0, and we say that the divisibility by 0 is undefined. Mathematicians still don't know what happens when you divide by 0, so we just say it's not defined when we divide by 0. 1 over 0 is undefined. If it was 0 over 1, that's different, that's 0. So 1 over 0 is undefined. So now we've got some more values of theta that we can work out the exact value of sine, cos and tan. We've already seen the 30, 45 and 60 triangles. Now we've got sine, cos and tan of 90. But as they say, wait, there's more. If we have a look at P0, P0 is where P started from. Well, let's move that over a bit more there. There we go. Let's have a look down here. P0 will be here. Go back up to the diagram, P0. And P0 is where x is 1 and y is 0. Looking at the diagram back up the top here. So let's go down and work out that. So P0 has the coordinate 1, 0, and theta is equal to 0. Okay, so the sine of 0 degrees, sine is equal to the y-coordinate. The y-coordinate is equal to, y-coordinate here is equal to 0. Sine of 0 is 0. The cos of 0 degrees, cos is equal to the x value, which is equal to 1. And the tan of 0 degrees is the y-coordinate divided by the x-coordinate, 0 over 1. And 0 over 1 is defined. 0 divided by 1 is equal to 0. So here we have the sine, cos and tan of 0. At P2, going back looking at the diagram up here, P2 is out there and P3 is down there. Alright, so rather than go through all those, you can actually work out just write down what they are. At P2, the coordinates, looking at our diagram, is -1, 0, and theta equals 180. And at P3, which is down there, and the coordinates are 0, -1, theta equals 270 degrees. And we can work out sine, cos and tan of 180 and sine, cos and tan of 270. Before we leave this, we should also be able to work in radians. So at P1 up here, theta is 90 degrees, or what's that in radians? So that's pi on 2. So you can say that the sine of pi on 2 is equal to 1. The cos of pi on 2 equals 0. And the tan of pi on 2, exactly the same value as here, undefined. And if we continue that down here, we've got theta equals 0. Well, that's the same. 0 is the same in degrees or radians. 180 or pi, and 270, theta will be equal to 3 pi over 2. Lastly, before we leave this, we should also be aware that 0 is exactly the same as if you've done one complete revolution. One complete revolution is 0 degrees or 360 degrees, and if you're working in radians, it'll be 0 radians or 2 pi radians. And one more little bit. If we go all the way around, let's just use another pen and have a look at our diagram here. If we go all the way around there, that is going 270 degrees. The angle that would be at the centre of P move from there all the way around to P3, it would have gone through 270 degrees. Likewise, it would have gone, it will end up at the same spot down here at P3 if it starts here and goes in the negative direction around there. So you will find that the sine of 270 degrees is exactly the same as the sine of -90 degrees, because 270 goes around to there and you get to P3, -90 gets you around this way, coming in the negative direction gets you to the same spot. Likewise for cos and tan, it'll be the same. Okay, so it'll be cos and tan there. So 270 sine, cos and tan is exactly the same as -90, and positive 180 is the same as negative 180 because you end up at point P2, and so on.